Yeah, hello everyone. So let's start. So when we're talking about AI models, we can actually classify them through the different perspectives, and one of them is modalities. So historically, models wasn't multimodal; it was per purpose, usually text to text, and now there is available more, like text to image, image to image, voice to text, voice to image, and so on. There is a lot. Also, multimodal presented as well, but like it could be worse in some cases than specified. For example, text to image models. Usually it's not ChatGPT. I don't remember the market examples because it's not different. It's not my area, but designers can talk you more about that. They know it's better. So this is like the first classification. It's modalities. So it depends on your purpose. So if you have something really specific or you want to achieve better accuracy, probably it's better to investigate the modalities, possibilities, and what's accuracy of language or text recognition they have, and to see some benchmarks just to have the broad overview of that. And the second classification is kind of more per purpose, let's say, and there are several domains which tend to use some specific models. It is finance, it is healthcare, it is legal, scientific research, and robotics. Why they use specific? Because like they need specific training sets for the purpose. So for example, for legal, they have a bunch of slang which used in the documents and which cannot be interpreted the same way as like the general model cannot interpret that well. So that's why like it's specified. And also, yeah, for example, finance domain has their own Bloomberg GPT, which is fine-tuned version of GPT, FinBERT, which is fine-tuned version of BERT, and the rest of the fine-tuned versions of general purpose model. And yeah, about general purpose models for fine-tuning, usually it's Llama. I don't remember why it was chosen. Probably it has the good major capabilities like context window and so on, but a lot of cases with fine-tuning happens on Llama. And it's open source, of course, so you can have your own instance of Llama in your environment if you have a hardware for that. So the next topic, it is optimization of general purpose models. And here we can kind of make we can just split the flow. For example, like if we have a flow, like we need to recognize text, then I don't know, just classify some stuff from that, or just identify the emotions in that text, and then we should kind of respond with that data. So all of that could be split into the pipeline. So for the text recognition, we can use one model. For the classification, when we can use another model, and for the last step, when we're providing the answer, we can use the big general purpose model. So in this case, we can optimize flow with using not with just saving tokens of using the general purpose model, which is big and expensive. So we just removing some of the steps for that model to the more cheaper models in front of that. So we use the general purpose model, which is expensive, only at the end. This could save cost and speed up response, because like if all of our pipeline will be handled by the same general purpose big model, it will be long, because usually there is the tendency that the bigger model is, the bigger latency, so it responds longer. So that's why you can just switch to the more lightweight models on the some steps of pipeline to reach faster requests. And it is usually critical for the chat application. So if we're talking about workflow, it's not the case, but I wouldn't dive deeper here about the workflow. And also there is sometimes you need to have self-hosted models, and that could be needed for fine tuning or for security reasons, because every time you send any data to GPT or Anthropic or whatever, some big markets provider, you just expose your data. And to prevent that, you can have your self-hosted model. It is like the model instance which installs on your own hardware, which means it doesn't expose the data to the world or to some provider. And you can kind of isolate your work in this way if you need extreme security. And referring to the previous topic, usually it's critical in finance, sometimes in legal, and sometimes in healthcare. That's why they tend to have their own models. Yeah, the major providers for which provides hardware or just in general infrastructure for self-hosted models is the Bedrock, Azure Cloud, and also I've seen some software as a service solutions. But better to Google, because I don't remember exact ones, so just the general overview. Yeah, also want to mention, in addition to the previous topics, that there is also the limitation about context window, which is critical, and sometimes it could be useful. For example, latest Gemini has a twice bigger context window than Claude, which could be useful. And context window, that helps you to kind of focus model on specific task in a moment of time. You can reach that with providing a history of messaging to the context and so on, because between the messages, model usually loses the point, loses the point of the discussion, and bigger context window helps to handle that. Yeah, and here is the useful links. So the first one is Hugging Face. It is a hub with open source models, and there is a lot of stuff. You can just check there, like what's available. They also have specific domain models there. So yeah, just the general open source resource, which is pretty useful even to watch, even if you don't use anything from there. It also has a filter regarding modalities and with ratings and all of that stuff, so you can use what's trending right now and why it's trending, what's capabilities, what problem it resolves. Usually it has some explanations or papers. Also, it has a leaderboard, which is also useful, and yeah, the same purpose is just decision making, what you will choose, and just comparison of some models. The next resource, it's artificial analysis. This is useful for decision making, especially when you're building the pipelines with several models, because it provides comparisons across many sides of the models. It is performance, it is some capabilities, it is reasoning, it is cost, and so on. So it's just kind of benchmarking, let's say, so you can see how different models are evaluated. The next one is LLM Arena. This one is specific because it's kind of benchmarking by users. So there is the model provided to user, and user uses that, and that and after the usage makes an assumption how good it is in comparison with another one. And the main point of that model is hidden by itself, so you can't know when you're evaluating which models you are using in the model. So it's kind of preventing the bias and so on. They also have their own ratings, and the main point of that, like just the user evaluated models. Next one is Helm. Helm, it's more about academic and research benchmarks. It also has ratings, has papers, so just to check it. Also could be useful information there for you. In addition, you can use just the LLM benchmarks, one of which is MMLU. And there is more. You can just read what's the point of the benchmark, which capabilities it checks, and so on. As I remember, MMLU checks it from different capabilities and as a general purpose, like randomly putting some topics with different difficulties to the model and then evaluating the results. Yeah, and the last point here, it is major AI company benchmarks. The problem with them that they could be biased because it's partially a sales material. So if some provider presents a new model or a new version, let's say Anthropic release the next generation, obviously they will fine tune a bit some benchmarks or model itself to fit some benchmarks to get a better view about that. And they will present that as a paper on their website. So yeah, they could be biased, but in some points, but in a general points, it's useful to check, for example, like, I don't know, context window, some major capabilities, and so on. Yeah, that's probably it from my side. If you have some questions, just ask. I will try to answer on them.
Super interesting. I even share my screen. I made some notes. I can say them louder. You can just read them up. I have a lot of questions.
I was pre-trained models with RAG when the main point is external data. I didn't get the point. What do you mean pre-trained models? Fine-tuning usually don't use with RAG. Right.
Yeah, it's fine-tuning, I think, Thomas.
Yeah.
Fine-tuning. Fine-tuning.
Yeah, I can shortly explain what is fine-tuning. Like, the main problem with fine-tuning that you couldn't do this frequently because it takes a lot of resources to kind of force model to gain new knowledge. And that's why RAG was invented, because RAG allows that. RAGs, it's kind of outside of the model itself, and you can put there the data with any kind of latency. So you kind of avoiding this step of training with RAG. You just kind of extending the model instead of training. Training sometimes needed, but on the data sets which doesn't move quickly. Let's say you have some legal codex. For example, you have the general purpose model, you live in Ukraine, you have several legal codexes which doesn't move frequently, and you just use them to fine-tune your model to perform on Ukrainian legal codexes. So that's the case. So that's the case for fine-tuning, because like they don't move frequently, they don't have updates on some basis and so on. So that's, I don't know, in general what's.
And it's very expensive to do.
Yes, and it's also very expensive, of course. Fine-tuning, it's expensive because it takes a lot of resources. What it takes to train on models, assume they are always trained on a base model.
So my question is, let's say, for example, I was 25 years old and I set up an AI startup where I'm going to focus on something geared toward construction industry, right? And I want to build my own model, which I assume is always a pre-existing model. That's my question.
Yeah, there is several methodics how to make training. One of them, which is usually popular and used in majority of fine tunings, it's LoRa. It is this. Yeah, I just don't remember all of the details, but the main point of that you kind of froze in the base model, some part of the base model, and on all of the rest you perform the fine-tuning, because the main fine-tuning problem that if you wouldn't froze some of the core or some of the base tensors, like it will just randomly forget the previously trained data. For example, it could decrease on language recognition capabilities and so on, and it could happen randomly. So LoRa, no, it's LoRa.
LOLA.
R here. Yeah,
Oh,
big R.
Mhm.
Yeah. How many base models estimate? That's actually a good question. There is a lot. Like historically, there was only one. It's BERT, and everything started from BERT. And no, BERT, BERT, and its abbreviation. English E. Yep, this one. It had only completion capability at the start, and later it was grown to GPT and all of that stuff. So architecture and all of that stuff, and also fine-tuning, it was really good described in a book, Hands-on LLM. So if you read this, you can kind of grasp all of the main concepts. How expensive computing wise are the models, memory, storage, and etc.
Meaning, if you're hosting it yourself.
Like, as usually, here is the answer: it depends, but it depends on the model itself. Like, the bigger models are, the bigger resources, especially video memory resources, you need. Because I remember Llama with 7 billion parameters needs kind of 130 gigabytes in memory, in video memory, and that's a lot. That's really a lot. So self-hosting, it's kind of really expensive, but sometimes it's needed. So, and also it depends how you organize the process. As I already mentioned on a pipeline section, you can optimize that by having a model with less parameters. Like usually models released in a family, like from small to bigger, and you can just choose smaller for such cases, because like in this case you will save some money. And usually if some tasks performing good on a small tier models, it will perform even better on bigger tier. So that's for the case if you want to kind of, if you have more money and can afford a bigger tier in the future. How to implement the pipeline technically, some patterns. Yeah, like it's similar for the building pipeline, for deploying pipelines. So it could be done as a deploy pipeline. It could be done, yeah, usually it's kind of deploy pipeline. So you have just some steps which goes one after another.
I think here there exists like in Python, popular library like Torch. So it's kind of, yeah, there will be three lines of code like to write. Basically, if you have the existing model and based on which you want to learn, and the next step you should provide the data. I mean, like it's not so much there are like lines of code to do some pipelines for that. I mean, of course, if you are using this library. Also, I think, Thomas, if you want to kind of train your model, like just for learn, you can search Nano GPT model. It's very popular. Yeah, Nano GPT. So basically, this is kind of how it was the first GPT. It's similar to that. So I think you can spend there basically description. I mean, like if you go in this repository, it's like GitHub repository, you can spend around $300 for like some video cards, and you can run it on your data, train it on your data.
Oh no, it's that part is
Nano
super interesting.
GPT, not GPT, but GPT. Yeah, like generative. Yeah, so basically there is also the code. You can see how the GPT is working. I mean, like,
interesting. I that's my main takeaway after when I started thinking about the models, right? Because there's going to come new businesses. Is maybe this where we should focus? I don't know. It was super interesting after. Thank you very, very much.
Oh yeah, and also one thing which referring to the previous discussion, it's like major providers, they don't expose their training sets. For example, like Anthropic, OpenAI, like they models, we don't know which sources they used to train them. So that's why sometimes like such closed source code models, you have to just manually check for some capabilities because like they could perform differently at the same task. And the problem is that they don't expose training sets. So working with AI is always a journey.
Yeah, sounds like engineering. Yep.
Yeah, but on Face exists like this data set, like open web. So basically they kind of download the entire web. So it's kind of an archive with a lot of data. I mean, just if you want to train your model. But of course, I mean, like you are not sure which kind of data is there. So it's a lot of mess. So.
Yeah, Luda, you had a question. Yeah, Artem, what do you think is like meaningful minimum requirements for running local models? And my question is based on, I tried to download a Llama some time ago, and I downloaded this GPT 20 bytes. So basically it says that it requires as little as 16 gigabytes of memory, and I had that. But basically when I tried to run it, it's like I said hello, and it took maybe, I don't know, 20 minutes to respond to me. And after those 20 minutes, I just quit it because it's just not working locally. What do you think is kind of minimum requirements to have on local machine to run those models?
You can try something smaller because Llama is kind of more advanced stuff. So just take something smaller, like Nano GPT. It could be smaller. As I remember, it is smaller, and Bird also pretty small and widely useful for local experiments. So yeah, just okay. Like the general recommendation, just take the smaller possible. And
I think here, Ludmila, I can answer a bit differently. So can you share again your screen? So basically, this Llama, you can download it with different amount of parameters. So I saw there by default you have like
20, and I downloaded OpenAI minimum version, like, so this is the one. But yeah, I know that we can download different tools there. Though I was
even like you can try with Llama. So you can go in the Llama. So Llama have different versions. Like, so of course, if you like download with more parameters, it is smarter. But of course, it is using more resources.
This one?
No, but can you open the Llama? I think I saw it. And the UI.
Okay.
So you see there GPT.
So just try like Llama version.
It was sometimes, but I think there is like Llama. But
Yeah,
I mean, like I also was I use it like locally, but I use it like you can try this to use like less parameters, and after, for example, if you work fine, I mean, like good, you can like download one more like with more parameters. So I will send maybe to you the link.
thank you. Yeah, I was just curious if Artem is working with some of the models locally. How much of the CPU and memory does he have?
Yeah, I tried only Bird locally, so it was enough. And yeah, usually I try to choose as small as possible because, like, yeah, it's greedy for resources.